So we're going to look at the next calculations, and the next calculations are about, first of all, ratios. And we're looking at the ratios here to do with hydrogen carbonate, which is this, which is carbonic acid, and the carbonic acid goes into HCO3 minus. So this is your A minus, this is your HA. So this is what happens in your blood, and you use this acid, carbonic acid, to regulate the pH in your blood. So what they do is they ask you a question about, one, why is it a buffer? And we've gone about that in another video, okay? But they also talk about what's the ratio between the A minus and the HA? And actually it's not a really complicated one to do, but let's have a look at it anyway. Okay, so we have got our H plus, and this is a real tip, a real important tip. If you are given a pH, always just convert it into H plus. Because you can convert it, if I go across here, you convert it, H plus equals 10 to the minus pH. Okay, so basically I can just convert it straight to H plus. So I've got my H plus already. Now, in the question, they give you pKa of 6.38. So we'll convert that into Ka, and I'll see I've converted it here, but using the same thing. So the same thing here is Ka to 10 to the minus pKa. So I've put in 6.38 there and converted it into Ka. So there you have your two values of H plus and Ka. Now what you can then do is you've got your concentration of your H plus, so you can put it there. You've got your Ka value, which is there, but you don't have your A minus, you don't have your HA. Now remember, your HA and your A minus is your HCO3 minus, which is A minus here, and your HA here. Okay, so we need to know what the ratio is between these two bits here. So we can rearrange that, and rearrange it by dividing by the H plus, and that gives us a ratio of A minus to HA. Now remember, you know this number because it's there, and you know this number because it's there. And you knew that because of the pH, and you knew that because of pKa. If that's the case, you can put those into the equation. So we put the numbers in, and you can get a ratio. Now, that ratio is 10.48 to 1. So why is it 10.48 to 1? Well, the answer you'll get will just be 10.48. So the answer you'll get will just be this. But 10.48 is the same, okay, as 10.48 over 1. Okay, so therefore the ratio is 10.48 of the A minus to 1 of the HA. And that gives you your answer as to calculate the ratio in healthy blood. So you would have to say HCO3 minus and H2CO3. So if you're doing it, make sure you put those into the equation. We've just shortened it to A minus HA just to make it a bit smaller to fit on the screen, okay? But that is how you do any ratios, and they could ask you any ratios of anything. So just rearrange it so that Ka is over H plus. They'll have given you information to work out Ka. They'll have given you information to work out H plus. All you do is plug the numbers in, and then the number you get, put it over 1, and there's your ratio. In our last question, we're going to calculate the concentration of A minus and the mass of A minus used to make it in the first place. We're given all this data, pH of 3, which means we can get an H plus concentration from that. We've got a Ka value. We've got some concentration and volume of the CH3COH or the HA. Okay, and we've got a new total volume of 400 to 500. This is a conventional buffer with weak acid and conjugate base. So if we then go from there, here's our equation. And we're going to do the same thing. We converted straight away our pH into H plus, 10 to the minus pH. Look up there, okay, to the equation. We then are doing the same thing we've done in all of the other rest of the questions. 400 centimeters cubed is from 0.4 decimeters times the concentration gives you the moles of HA. Okay, we then find the new concentration of HA by dividing by the total volume. Okay, and we've got a concentration. Let's put those down to the bottom. Okay, and then we've got our equation here. We need to then have our Ka to put the numbers in. So we've got this, and we've got this. And the expression looks a bit like this. Okay, now, if that's the case, we need to rearrange it. So we rearranged it just so that we can equal the A minus, which we need to calculate. Okay, and then we start putting the numbers in. So we put all the numbers in. I'll get out of the way here so you can see. Okay, so we put all those numbers in. Okay, now that number over there is our Ka, then we've got our concentration, then we've got our H+. Put those all in, and then you've got this lovely concentration here. Now, normally you'd put it 3 sig fig as a final answer, but we're not doing that because we're going to use that to work out the mass of the A-. So first of all, we need to know how many moles of that there was. Okay, and we've got the number of moles that we've got there, so that's our number of moles. And from the moles, remember we worked this out through volume times concentration, so we just took that concentration, times it by the total volume, which is 900 centimetres cubed, 0.9 decimetres. Then we use this equation, which is the first one you use when you come across your A levels, really. Okay, and we rearrange it so that we got mass equals moles times mR. Put that in, and you have got your answer. That is how much mass was used, and that is the concentration of the A-. And that is how you use some complex information to work out your A-. In the next video, we'll talk about how you can just look at pKa and a group of acids and say which one is the best acid to make my buffer of a certain pH. And that'll be the last question we do for buffers.